So here we're going to fill out the graphic organizer for the states of matter. So I'm drawing my curve for what it's called a heating curve would look like as we go from a solid to a liquid to a gas. So I'm going to drop in some pictures of our water demo. So this is where we went from solid water or ice to liquid and then boiling. And so our boiling liquid shows both the liquid and the gas. So water freezes or melts at 0 and boils at 100. So anytime we go from a solid to a liquid, it's called melting. Every time we go from a liquid to a gas, it's evaporating. Going the other way from a gas to a liquid is called condensing. And going from a liquid to a solid is called freezing. We're going to look closer at solids here for a second. So particles in a solid are packed really tightly together. They're nice and organized. They're not always necessarily stacked directly on top of each other, but they have a definite shape and a definite volume. They're tightly packed. They only move a little bit. They have strong intermolecular forces, or IMFs. So that means they have strong attractions between the particles. So I said a minute ago that they move really slowly. So we're going to draw little lines that we call whooshies to show that they're moving. They're just not moving very fast. So now we're going to look at liquids. So liquids are a step up from solids. So the particles are spaced farther apart. They're moving a little bit faster. So we've got a little bit longer whooshies. Liquids have indefinite shapes. So that means they take the shape of whatever container they're in. They do have a definite volume though. They can't be expanded or contracted or compressed. That's what I meant. So there's free motion in liquid particles. They have significantly less intermolecular forces. There's still some attractions holding them together, but they're just not very strong. And they're moving a little bit faster than solids. They're moving at a moderate speed. So as we go from a solid to a liquid, you're doing two things. You're increasing the motion and you're breaking the attractions. And as we go the other direction from a liquid back to a solid, you have to slow the particles down and you have to form those attractions or those intermolecular forces between the particles.